U.S. secret spaceplane tests aerodynamic braking. The U.S. Space Force's X-37B spaceplane is testing aerodynamic braking and will perform a series of unprecedented maneuvers to change its orbit. The autonomous X-37B has been flying in a secret, elongated elliptical orbit for 10 months since its launch during its 7th mission on a SpaceX Falcon Heavy rocket late last December. The spaceplane has been conducting experiments on radiation effects and testing satellite tracking technology known as space domain awareness. Now, the X-37B will begin using Earth's atmosphere to modify its orbit, according to a report by Space on October 11th. A series of aerodynamic braking maneuvers will harness the drag from Earth's atmosphere. This technique will allow the X-37B to lower its orbit while using minimal fuel, according to the U.S. Space Force. After transitioning from a high elliptical orbit to a lower circular one, the spaceplane will release its service module components. These components will remain in orbit for a much shorter time than if they had been released in a higher orbit, thereby reducing space debris. This marks the first time the X-37B has performed aerodynamic braking. The test builds upon the previous X-37B missions and decades of insights from the scientific community through various lunar and Mars missions. According to U.S. Space Force Commander Chance Saltzman, the series of maneuvers by the X-37B is a crucial milestone. Following the aerodynamic braking, the X-37B will continue with its testing objectives. The spaceplane will then deorbit and land, as it has in its 6 previous missions. The current flight is known as OTV-7, Orbital Test Vehicle-7. The spaceplane first launched on a United Launch Alliance Atlas V rocket in 2010. Its OTV-6 mission, launched on SpaceX's Falcon 9 rocket, remained in orbit for 908 days.